Imagine a world where the sun never sets for decades at a time, only to be shrouded in darkness for an equally long winter. A place where the concept of day and night is stretched to unimaginable extremes. This is Uranus, the seventh planet from our sun, a distant, icy giant that defies the norms of planetary behavior. Unlike the other planets in our solar system, Uranus spins on its side like a giant marble rolling across the cosmos, presenting a unique and fascinating spectacle. Unlike its planetary siblings, Uranus exhibits a bizarre 98-degree tilt in its axis of rotation. This means that its poles are where most planets have their equators. This peculiar orientation sets it apart as the solar system's true oddball. No other planet in our solar system has such an extreme tilt. Why is Uranus tipped over so dramatically? What could have caused such an unusual orientation? What cosmic events could have conspired to create this celestial anomaly? Was it a colossal collision with another celestial body, or perhaps a series of smaller impacts over time? The answer, like the planet itself, remains shrouded in mystery. Despite our advanced technology and understanding of the cosmos, Uranus continues to baffle scientists. However, scientists have proposed several intriguing theories to explain Uranus's unique tilt. Some suggest that a massive object, perhaps the size of Earth, collided with Uranus billions of years ago, knocking it over. Others believe that gravitational interactions with other giant planets could have gradually altered its tilt. The quest to understand Uranus's tilt is ongoing, and each new discovery brings us closer to unraveling the secrets of this sideways world. In our solar system, most planets spin on their axis with a slight tilt. This tilt is a crucial aspect of their behavior and has significant implications for their climates and seasons. Earth, for example, has a tilt of about 23.5 degrees, which gives us our seasons. This tilt causes the variation in sunlight that different parts of the planet receive throughout the year, leading to the familiar cycle of spring, summer, autumn, and winter. But Uranus takes this to the extreme. Unlike Earth and most other planets, Uranus has an axial tilt of about 98 degrees. Its near sideways rotation means that its poles point almost directly towards the sun for part of its orbit. This unique orientation results in one pole being in constant sunlight for about 42 Earth years, while the other pole is in darkness for the same period. This extreme tilt has profound effects on Uranus's climate and seasons. The planet experiences extreme variations in temperature and weather patterns, unlike anything we see on Earth. Imagine summers that last for decades, where the sun never sets, followed by equally long winters of perpetual darkness. These prolonged periods of light and dark create unique atmospheric conditions and weather phenomena. This strange orientation makes Uranus a fascinating subject for astronomers studying planetary dynamics and the evolution of solar systems. Understanding Uranus's tilt and its effects can provide insights into the history and development of our own solar system, as well as the potential for similar phenomena in exoplanetary systems. One of the most dramatic theories proposed to explain Uranus's tilt involves a cataclysmic collision early in the solar system's history. Imagine a young Uranus still forming from the swirling disk of gas and dust, when a massive object, perhaps a rogue planet or a colossal asteroid, slammed into it with incredible force. The impact would have been powerful enough to knock Uranus off its axis, leaving it permanently tilted. This single catastrophic event could explain the planet's extreme axial tilt and its retrograde rotation, where it spins in the opposite direction of most other planets in our solar system. While a single massive impact could explain Uranus's tilt, some scientists believe a series of smaller impacts may be responsible. In this scenario, Uranus would have been bombarded by a barrage of smaller objects during the early stages of the solar system's formation. These impacts, while individually less powerful than a single massive collision, could have cumulatively altered Uranus's rotation over time. Each impact would have nudged the planet's axis slightly, eventually leading to its extreme tilt. This theory suggests a more gradual process, with Uranus's orientation slowly shifting over millions of years. Beyond impact scenarios, another theory proposes that gravitational interactions with other massive bodies in the early solar system might have tipped Uranus over. Jupiter and Saturn, the solar system's two largest planets, exert a powerful gravitational influence on their neighbors. Some scientists theorize that during the early solar system's chaotic period, these giants may have migrated closer to Uranus. Their combined gravitational pull could have gradually tilted Uranus's axis over millions of years. This theory suggests a more subtle, dance-like interaction between these celestial giants, ultimately leading to Uranus's unique orientation. Our best glimpse of Uranus came from the Voyager 2 spacecraft, which flew past the planet in 1986. Voyager 2 beamed back stunning images of Uranus's faint rings, its icy moons, and its surprisingly active atmosphere. While Voyager 2 provided invaluable data, it couldn't definitively solve the mystery of Uranus's tilt. The spacecraft's brief flyby left many questions unanswered, highlighting the need for future missions to unlock the secrets of this enigmatic ice giant. Adding to its list of oddities, Uranus possesses an incredibly unusual magnetic field. Unlike Earth's magnetic field, which is roughly aligned with its axis of rotation, Uranus's magnetic field is significantly offset from its spin axis. This misalignment suggests a complex and dynamic interior. Some scientists speculate that the planet's internal structure, perhaps a layer of electrically conductive fluid, might be responsible for both its peculiar magnetic field and its extreme tilt. To truly understand why Uranus spins on its side, we need to send a dedicated mission to this distant world. A future spacecraft, equipped with advanced instruments, could orbit Uranus for years, studying its atmosphere, its magnetic field, and its internal structure in detail. By analyzing the data from such a mission, scientists hope to unravel the mysteries of Uranus's tilt and shed light on the processes that shaped our solar system billions of years ago. Uranus, the sideways planet, continues to captivate and intrigue us. Its extreme tilt, its unusual magnetic field, and its icy composition make it a unique and compelling target for scientific exploration. Each new discovery only deepens the mystery, reminding us that our solar system is a place of endless wonder and surprise. Perhaps future missions, peering beneath Uranus's cloudy veil, will finally reveal the secrets behind its bizarre tilt and shed light on the chaotic early days of our solar system. As we explore the cosmos, we are constantly confronted with new wonders and mysteries. The vast expanse of space holds secrets that have intrigued humanity for centuries. From the swirling galaxies to the shimmering nebulae, each celestial body tells a story of creation, destruction, and the intricate dance of cosmic forces. Uranus, with its sideways spin and its enigmatic nature, serves as a powerful reminder that our universe is a place of endless possibilities. Its unique tilt and faint rings challenge our understanding of planetary formation and dynamics. This ice giant, with its mysterious atmosphere and hidden secrets, invites us to delve deeper into the unknown. It is a place where the familiar laws of physics can create objects and phenomena that challenge our understanding and ignite our imagination. Black holes, with their immense gravitational pull, and neutron stars, the remnants of supernovae, are just a few examples of the extraordinary entities that populate our universe. These phenomena push the boundaries of our knowledge and inspire us to seek answers to the most profound questions. By studying these cosmic oddities, we gain a deeper appreciation for the diversity and complexity of the universe we inhabit. Astronomers and scientists, with their relentless curiosity and advanced technology, continue to uncover the secrets of the cosmos. Their discoveries not only expand our understanding, but also fuel our imagination and drive to explore further. And as we continue to explore, we can be sure that the cosmos will continue to surprise us with its boundless capacity for wonder. The journey of discovery is far from over. With each new mission and each new observation, we inch closer to unraveling the mysteries of the universe, always aware that the next great revelation could be just around the corner.